Let's practice with some converging lenses. So converging lenses, we give a generic shape as looking kind of like this. Basically, they're thicker in the middle than they are on the edges. So it's really thick across the lens here, and then they come to points on the edge of this lens. Okay, and many lenses that we work with are like this. All right, so we'll draw an axis, an optical axis through this lens, straight through the center, and we're going to determine its focal points. Okay, and no matter the curvatures, the focal points are the same on each side. Okay, now with that, we're going to try and find the image of something, of an object that is outside the focal point. So what if I have an object here? I'm going to use an arrow just to indicate it, to indicate my object. This could be a tree or a person, but by having this arrow, I can differentiate between the top and the bottom. Okay, so you can see if the image gets inverted or upright or whatever it does. Okay, so in this particular case, we can start with our parallel ray that goes straight through to that the plane of the lens, and then it's going to come out of that lens going through the far focal point. Okay, that's our parallel ray. Then we'll have the focal ray, which will go through the first focal point and come out straight. Okay. Comes out straight through the on the other side of the lens. And then our checking ray, our central ray, we can go through the center, and indeed it does check out that our point of focus is right there. Our image will focus clearly right there. If we stuck a piece of paper right along here, we would see an image of that arrow forming upside down on that piece of paper. Okay, so this is one example. Now something that's interesting is we can actually figure out fairly mathematically where it ought to be because of the triangles that are here. Okay, this is a parallel ray and then goes through that focal point and they meet at this vertex. Here's a ray that goes through this focal point and then comes out parallel. We could do a lot of math of similar triangles to figure out where it is, where the image forms based on where the object is. Okay? Now what we should do is kind of just use these to check, but we have some math that we'll get into later to be able to predict where it's going to be, and then we can check it with a lens diagram. Okay, well, what if, let me redraw it. Now, instead of drawing the curved surfaces, since we really only care about this middle plane, I'm just going to draw that plane. Do a little bit bigger lens this time. Okay, here's a focal point, and here's a focal point. What if my object is actually inside the focal point? So this might be the case like a magnifying glass, where I'm holding a magnifying glass really close to an ant or something like that. And so the focal point actually is beyond the object. So here's my arrow, here's my object. My question is, where is the image going to form? Okay. Well, let's follow those same rules we had, but we just need to be a little more careful. So I still have a parallel ray that comes in parallel, okay, parallel with this optical axis, and it's going to go through that far focal point. That doesn't matter if this object was over here, it would have still come in parallel, come through that far focal point. So that's the same. But our focal ray, up here in this case, we said it goes through the focal point on the same side and then out parallel. Well, the focal point's on this side, so yeah, I guess there is a ray that's going from here through there, but it keeps going this way, and that doesn't ever get to the lens. And so what am I talking about if I'm inside? What kind of ray do I have? What you think about is there is a ray coming off that arrow from the direction of the near focal point. Okay, so there's a ray coming off this way, and it's as if it's coming from that focal point. Just like this ray comes from that focal point, if it started here and gone this way, it would have still converged over here. And so it doesn't matter where it starts as long as it's coming as if from that focal point. So this one comes as if from this focal point, and therefore comes out parallel. Okay, so the same rules apply. We just have to be a little bit more careful with what's going on here. Now you might be asking, well, those two rays didn't come together. They did not converge like we did up here on this case. What kind of image? I do see when I hold a magnifying glass up to an ant, I do see the ant. Let me ask you to think carefully. If you've ever looked through a magnifying glass at some object, where does that object appear to be? And if you think carefully, your answer will be that it appears to be on the other side of the magnifying glass. Okay? So here's how we can understand what's going on, is if we remember that these light rays are coming, and let's say my eye is over here, and these rays are entering my eye. Okay? I see this ray as if it's been coming from this direction, and I see this ray as if it's been coming from this direction. I can't tell that earlier on they bent. All I can tell, this one's coming from this direction, this one's coming from this direction. And so this one appears to be coming from a line like that, and this one appears to be coming from a line like that. And those do indeed converge. Okay? And, well, let's see if we can check that with our central ray, hoping that I've drawn these fairly well. So if I draw my central ray, it's going to go like that, and see, it doesn't converge with those, but if I take my line of sight back, it does converge up here. And so I end up with a bigger object. Okay, or sorry, the image looks bigger than the object, and it is on the same side of the lens as the object was. Just like when I look at an ant or a leaf through a magnifying glass, it appears bigger and on the opposite side of my eye. Okay? These rays enter my eye and appear to have come from this point. So this is where the image is. Now let me ask this question. If I put a piece of paper right here, okay, and instead of looking through the lens, I look just from the side, will there be an image on that piece of paper? Up here, that's the case. If I put a piece of paper right here, and this light, or the rays of light coming from this object go through that lens, hit there, I can look from the side, not through the lens, but from the side, and I can see an image there forming. But in this case, the answer is no, it won't form, because the light's not really coming from here. Only when I look through the lens does it appear to come from there. But if I look from the side, okay, looking from above or below or just from the side of this lens to this point in space, I won't see anything because the light's not really coming from there. Okay, so these three rays do appear to converge, and we call this a virtual image. It's not a real image. This is a real image. The light really does go there, but the light does not really come here. So that's two examples of lenses, of converging lenses. This is, we're getting a diverging effect here, creating a virtual image, and here we're getting converging rays that form a real image.